Good morning children, stay safely at home. So I am starting the next topic, static electricity. Alright, now the example of static electricity, everybody knows that if you comb your hair for several times, alright, and then you take small pieces of paper, then you will see that the comb, after combing your hair for several times, if you bring the comb near the small pieces, tiny small pieces of paper, then you will see that they get attracted towards the comb. This is one example of static electricity. Another example, winter is coming, and during winter you will see the quilt you are using, alright, or the comfort you are using, that if it is made up of nylon or silk cloth, then you will see that with a crackle sound sometimes a spark is produced, alright. So that is the example of static electricity. So why the term is static electricity? Because the body that is getting the charge remain at rest within the body. That's why it is known as the static electricity, and the charges which are at rest within the body known as the static charges. Alright. Now, static electricity, how it is produced? If you want to know that, then you have to know the structure of an atom. What is the origin of the static electricity? If you want to know, then you have to know what is the structure of an atom. Now, what is the structure of an atom? Alright. Now, the entire mass of an atom, it is concentrated in a very small region at the center of the atom. This small region where the entire mass of the atom is concentrated is known as the nucleus. Alright, what is its name? Nucleus. Okay, Nucleus. Inside the nucleus, there are two types of fundamental particles. Alright, the first kind of fundamental particle is known as proton. Protons are positively charged particle. They carry positive charge within it. And what is the charge of one proton? Plus 1.6 into 10 to the power minus 19 coulomb. Alright. And neutrons, the second type of fundamental particle present inside the nucleus, known as neutrons. Neutrons are electrically neutral particle. What does it mean? Neutron has no charge. Alright. Another important point regarding proton and neutron is that mass of proton almost equal to mass of neutron. Okay. And neutron and proton, as both of them are residing within the nucleus, their common name is nucleons. Nucleons. Alright. So whatever I said, I have noted down here point wise, that entire mass of an atom is concentrated in a very small region at the center of the atom. This region is known as nucleus. Second point, inside nucleus there are two types of fundamental particles. First type of fundamental particle is proton. It is positively charged particle. Here you see I have written QP. Q is used to represent charge of a particle, and P stands for proton. So QP means charge of proton. How much? Plus 1.6 10 to the power minus 19 coulomb, because you know SI unit of charge is coulomb. Then neutron, it is electrically neutral particle. Another is mass of proton. M stands for mass and P is the subscript. So mass of proton almost equal to mass of neutron, and protons and neutrons together are known as nucleons. Nucleons. Now, surrounding the nucleus of an atom, there are different orbits as it is shown here. If you consider this is the nucleus, small, that's why I have written within P and N. There are different orbits. Alright, here casually I have drawn. Actually, they are totally circular orbits, okay, surrounding the nucleus. Now, these orbits, they are named as KLMN starting from the nucleus. Means the orbit nearest to the nucleus is known as kth orbit, then next is L, next is M, then next is N, so on. Alright. And every orbit can accommodate maximum number of 2n square electron. Alright, they may have less than 2n square electron, but no orbit can have electron more than the number 2n square. Alright, now here what does n stands for? N is known as the principal quantum number. Alright, and n is equal to 1 for kth orbit. So you see, in kth orbit maximum 2 electrons can be accommodated. Like that, if you consider the L orbit, for L orbit the value of n is 2. So you see 2n square, 2 into 2 square, how much? 8. So L orbit can have maximum 8 electron. It may have less than 8 electron, but it cannot have more than 8 electron. Like that, the mth orbit, for mth orbit n is 3 and 2n squared is equal to how much? 18. So m orbit, it can accommodate maximum 18 electron. Alright, I am repeating again the fact that any orbit may have less than 2n square electron, but no orbit can have more than 2n square electron. Alright, another important fact is that electrons are all negatively charged particle. You must remember this, that electrons are all negatively charged particles. Now inside an atom, the number of proton inside the nucleus and number of electron in the outer orbit, they are equal. Alright, and not only that, charge of electron and charge of proton, they are equal. So you see what is happening inside the atom, the total amount of positive charge and total amount of negative charge, they are equal. And as you know that positive and negative charge, they cancel their effect each other. That's why atom as a whole electrically neutral. Very important concept. Why atom as a electrically as a whole it is electrically neutral? Because number of proton and number of electron inside an atom are equal, and proton and electron, they are having same amount of charge but opposite nature of charge. Alright, same amount of charge, both of them are having 1.6 into 10 to the power minus 19 coulomb of charge, but one is having, electron is having negative charge, proton is having positive charge. So they cancel their effect each other and atom become electrically neutral. Alright, now if you consider the electrons which are in the inner orbit, they are nearer to the nucleus. So as they are nearer to the nucleus, what they do, they get attracted strongly by the nucleus. So we say that the electrons in the inner orbit, they are strongly bound to the nucleus. Now here I want to mention one thing, girls. I observed that some of you that I do not understand why you never follow in the lecture what I am saying. You just concentrate on the board what is written. Alright, you never bother what is said in the lecture. Just you remain busy in copying whatever is written on the whiteboard. That is a very bad habit. You must overcome that. Alright, those who are having this habit. And that's why after getting one video, you just lecture, you just start asking the ulta-pulta questions in the WhatsApp group and just irritate me. So again I am requesting everybody, not only you, I request your parents also, that you must take care that you just listen what the teacher is saying in the lecture. Alright, not only that, you will just copy for whatever is written on the whiteboard. Alright, so that's why once again I am saying that what happens inside the atom, the electrons which are in the inner orbit, they are nearer to the nucleus. The distance between the positive charge and the electron, they are less. So as the distance is less, electrostatic attraction is more. So we say that electrons in the inner orbit, they are strongly bound to the nucleus, and it is difficult to take out electrons from the inner orbit outside the atom. If you want to take out any inner orbit electron from the atom, lots of energy is needed. Alright, but if you consider the outermost orbit electron, they are known as the valence electron. Alright, now as they are the farthest from the nucleus, their distance is quite large. They are not near to the nucleus. So nucleus very feebly, very weakly, they attract the valence electron or the electrons in the outermost orbit. That's why we say that valence electrons are loosely bound electron. Alright, so get the concept clearly. Which electrons are known as the valence electron? The outer electrons staying in the outermost orbit of an atom is known as the valence electron. Alright, and valence electrons are loosely bound to the nucleus. That's why if you provide little bit of energy to the valence electron, then the electrons will come out from the atom. Alright, so this valence electron, they play the most important role in static electricity. Remember, the charges, that is proton, neutron, staying inside the nucleus, they do not have any role to play in static electricity. The electrons in the inner orbit, they also do not have any role to play in static electricity. Which one has the important role, or what is the origin of the static electricity? Solely due to the valence electrons. Alright, because valence electrons are loosely bound electrons, and easily by providing little bit of energy, you can transfer the valence electron from one atom to another. So whatever I have said, I have just here noted down that inside an atom, Np equal to Ne. N stands for number, P for proton. So Np stands for number of proton. So number of proton equal to number of electron. Charge of electron QE is equal to minus 1.6 into 10 to the power minus 19 coulomb. QP is equal to plus 1.6 10 to the minus 19 coulomb. So atom is electrically neutral. Then electrons in the inner orbits are strongly bound to the nucleus as their distance from the nucleus is less. Electrons in the outermost orbit of an atom are loosely bound to the nucleus as their distance from the nucleus is more. Then these electrons in the outermost orbit are known as valence electrons, and these valence electrons can easily be taken away from an atom by providing energy to them. Now what is the origin of static electricity? Static electricity, in most of the cases, it is produced by rubbing the two bodies with each other. Alright. Now, when you are rubbing the two bodies with each other, then what happens? Due to friction, heat is produced. And the valence electrons, when they are receiving this heat energy, after receiving the heat energy, they just get transferred from one body to another. Alright. So, what is happening? The body which is receiving electron, gaining electron, they are getting extra electron. Alright. Extra protons are not there to balance their negative charges. So what is happening? The body becomes negatively charged, and the body which is losing electron, what will happen to the body? The body will become positively charged. Alright, why? Because it is losing electrons, so proton will be extra within the nucleus, so the body becomes positively charged. Alright, another point you must remember, when you are transferring electron, you cannot break an electron and you cannot transfer a fraction of electron. So always electrons are transferred as a whole. So what happens? The amount of positive charge produced and amount of negative charge produced in static electricity, they are always equal by amount. Alright. So here, what is the origin of static electricity? That when two bodies are rubbed with each other, heat is produced due to friction, and valence electrons, after receiving this heat energy, are transferred from one body to the other body. The body which gains electrons become negatively charged, and the body which loses electrons become positively charged. And whenever electrons are transferred, as fraction of an electron is never transferred, so amount of positive charge and negative charge produced are always equal. So if the question comes that write in one sentence, what is the origin of static electricity? How you can write down the answer? This one I am just saying, okay, I have not written on the whiteboard. So I'll check it later on by putting the question. That if it is coming, that write down the answer, what is the origin of static electricity? How you can write? Transfer of electron from one body to other is the origin of the static electricity. Alright, whatever written here, 5 points I have written, that 5 point you can answer just in one sentence, that transfer of electron from one body to other is the cause of static electricity. Now the next concept is the concept of conductors and insulators. You know which are known as the conductors. Those who allow electricity to pass through them, they are known as the conductors. All metals are the conductors. Human body is conductor. Alright, fresh water is conductor. So these are the examples of conductors. And what are the insulators? Insulators are also known as the bad conductors. The substances which do not allow electricity to pass through them, they are known as the bad conductors or insulators. Alright. Now, why the conductors? They can conduct electricity because inside the conductor, valence electrons, what they do? They come out from the atom and they roam within the substance. They are known as the free electrons. The valence electrons which come out from the outermost orbit of an atom and stay within the substance. They are not staying within the atom, but they are staying within the substance. So they are known as the free electrons. Now conductors have large number of free electrons, whereas insulators do not have free electrons. Alright, these free electrons help electricity to pass through them. So the second point of difference between conductors and insulators are that conductors have free electron, whereas insulators do not have free electrons. So inside the conductor, as they allow electricity to pass through them, so they oppose less to the current. The opposition offered by a substance to the flow of current is known as the resistance. Alright, so conductor allowing the electricity to pass through them, so their resistance, opposition is less. Alright, whereas insulators, as they do not allow electricity to pass through them, their opposition to the current, their opposition to the flow of electricity is much higher. Alright, so I have written here the differences between conductors and insulators. So if you write down the difference, then what will happen? Then you can write down the differences also, as well as you can write down the characteristics of conductors and insulators also. The points written for conductors, they are the characteristics of conductors. The points written within the insulator column, they are the characteristics of insulator column. Example of insulator I have not said, but I know my children know it. What are the example of insulators? Rubber, plastic, all these are wood. They are the bad conductors or insulators. They do not allow electricity to pass through them. Alright. So what are the differences between conductors and insulators? That conductors, they allow electricity to pass through them. Insulators, they do not allow electricity to pass through them. Conductors have free electrons. Insulators do not have free electrons. Conductors' resistance is low and their insulators' resistance is high. Okay, so these are the differences between conductors and insulators. Now the next topic is how you can charge a body. Alright, now you can charge a body by three methods. One by one I am discussing. The first method already I have discussed, charging by friction. Alright, charging by friction. So what we do, that we rub the two bodies with each other, then electrons transferred from one body to other. The body which loses electron become positively charged, the body which gains electron become negatively charged. Alright, so the two examples, these two examples are very important. So you must learn and remember these two examples. When a glass rod is rubbed with silk, then what happens? Electrons are transferred from the glass rod to the silk. So what will happen? Glass rod become positively charged because glass rod losing electron, and silk become negatively charged. And like that, when an ebonite rod is rubbed by wool, then what happens? Electrons are transferred from the wool to the ebonite rod. So what happens? The wool become positively charged and ebonite rod become negatively charged. So these are the glass rod rubbed by silk is positively charged shows. Okay, and because I will use this one in the next two charging, and an ebonite rod rubbed by wool is a negatively charged body. Alright, these are the two examples you must remember. So this is the first method to charge a body, that is charging by friction. Now the next method is charging by conduction. Alright, conduction takes place when a charged body touches an uncharged body. Alright. Then what happens? That from the charged body, the charge is being transferred to the uncharged body, and the uncharged body gets the same type of charge as that of the charged body. Alright. So this process is known as charging by conduction. So for charging by conduction, 2 points are very important. You have to remember. What are they? The first point is that the uncharged body and the charged body should touch each other. Second point, the uncharged body will get same type of charge as the charged body. Alright. So consider these examples. Activities are given in the book. So these activities only I am discussing as example. Alright. So the diagrams I am drawing, that diagrams you don't have to write, don't have to draw in the notebook. Only understand the physics behind it. Alright. Now suppose this is the way you are doing. You have taken a glass rod. Alright. What is this? It is a glass rod rubbed by silk. So, glass rod rubbed by silk, what will happen? Glass rod will become positively charged. So, the glass rod is positively charged. Here there is a handle. This is insulating handle. Alright, this handle is insulating handle, because if you touch the glass rod, then what will happen? The glass rod, the charge present in the glass rod through your body will go to the ground. Alright, so that's why always insulating handle is this black portion is the insulating handle. I have not written it. Now suppose you want to charge this one, second body B. This is A and this is B is the uncharged body. And this uncharged body is also kept on an insulating stand. Alright, it is kept on insulating stand. So what you have to do, you have to touch these two bodies. So I am just doing this, I am making it bigger so that it touches. So they have to touch the two bodies. Alright, then what will happen? Actually what is happening, what you will observe, that from this glass rod A, positive charge will come to B. Is that clear? So you see what is happening? Charging by conduction. Why I am saying conduction? Because they are touching each other. Touching means conduction will take place. Is that clear? Not only that, you just look at the charge of the glass rod was positive, and what kind of charge B has received? B has received positive charge. Alright. Now understand actually what is happening. Positive charge means what? It is having less electrons. Alright. So suppose 1, 2, 3, 4, 5, 6 positive charge means 6 electrons are less here. And B is having 6 electron extra. Okay. So what will happen? The moment A and B will charge, then from B 3 electron will enter into A. So you see B is losing 3 electron. So B will become positively charged, and A, when it will receive 3 electron, this 3 positive charge and 3 electron, they will cancel their effect. So you see A is having less amount of charge and B is getting the same amount. The loss in A is equal to the gain in B. Alright, so as if the 3 charges A has given to B. Alright, so this is known as the conduction. So here when it is positive charge, then what I said, actually what is happening? 3 electrons are moving from B to A. This is the way I am representing the physics behind it. Okay, what is happening? From B, 3 electron entering into A. So what is happening? When B will lose 3 electron, it will have 3 positive charge, and when A will have 3 electron, A will receive 3 electron, then 3 positive charge, 3 electron, they will cancel their effect. So how much charge A will have? A, 3. So you see, during the charging by conduction, another fact is that the charged body loses its charge. Alright, what is happening? Charging by conduction. So this is another point you may note down, that the charged body loses charge. Alright, and this is the way it is happening. Now another example. Suppose you have taken an ebonite rod rubbed by silk, rubbed by wool. So when a ebonite rod is rubbed by wool, then what kind of charge it will have? This is the insulating handle. This is the black portion is the insulating handle. So it will have negative charge. Negative charge means what? It is having extra 4 electrons. Now you want to, this is A now. You want to charge the body B. So what you have to do? First of all, you will keep the body B on the insulating stand. Why on the insulating stand? So that the charge cannot go to the ground. Alright, that's why it is kept on the insulator. Now when it will touch, then what will happen? It is having 4 extra electrons. So electrons will go to the B. Okay, because it has extra electron and it has no extra electron. So generally what you do, so you see that this one, when charging by conduction takes place, then they are very generous. Alright, not like you, that you are having 2 chocolate, then your friend sitting next to you not having any chocolate, then you do not like to share the chocolate with her, isn't it? You just keep inside it and eat alone. But they do not do it. Some are not like that, some are, they are generous. So if any friend is sitting beside not having the chocolate and she is having 2 chocolate, then what the girl will do? A good girl, a generous girl, Carmelite, what they will do? They will give the girl will do, just share 1 chocolate to the girl next to her who is not having any chocolate, isn't it? So like that here also. A ebonite rod having 4 electron and B having none. So A will provide 2 electron to B. So you see what is happening. A is having negative charge, B is also having negative charge. This was uncharged first. Now B has become charged. But what kind of charge? Same type of charge. And another thing what is happening, the charging body loses charge. The charged body or charging body also we say, means the body which is charging the another body, that is known as the charging body. Charged body, it loses charge. Alright, so these are the examples and what is charging by conduction, and these are the examples of charging by conduction. Now next one is charging by induction. Alright, in this case what is done? The charged body is brought near the uncharged body, but the charged and uncharged body, they do not touch each other. Then what happens? Just I am giving one example. Suppose you have brought one positively charged body near an uncharged body. This is uncharged body V. You have brought it near. Okay. Then you see what will happen at the near end. At the near end, this is the near end, isn't it? This is the near end of the uncharged body. What will happen? Opposite charge will be induced. Opposite charge will be induced, and at the far end, same charge will be induced. Alright, you see here what is happening? Here positive charge you have brought. So here negative charge is induced and opposite same charge is induced. This is plus, same charge is induced. So this process is known as charging by induction. Charging by conduction is easier than charging by induction, because in charging by conduction what you have to do, you will just touch the charged body with the uncharged body, they will get the charge. But in this case it is little bit complicated. So you see, this is the first method. This is the first. You will bring it near. It is kept on the insulating stand. Alright, it is kept on insulating stand. So this is the first step. Then second step, what you will do? You bring it and then momentarily, means you just connect momentarily to the ground. Means it is negative and then you have connected it to the ground. This is the symbol, to the ground. So the momentarily when you will connect to the ground, then what will happen? These free charges, these are known as the bound charge. The near end charges are known as the bound charge, and the far end charges, same type of charges, are known as the free charge. So what will happen? These free charges will go to the ground, means they will be lost. Alright, so the moment you are connecting to the ground, then what is happening? You see, these far end charges, they are going to the ground, they are lost. Alright, then you see what you have to do, the third step. Third step is that first you will cut the ground connection. Ground connection is cut. You see, ground connection is cut. and then you remove the charge body. You remove the charge body. Then what will happen? These negative charges, they will spread themselves over the uncharged body and the body will become charged. So look at it. This is charging by induction. So when charging by induction taking place, then you see the charge body was positively charged, and what kind of charge you have got in the uncharged body? Opposite kind of charge. But in case of conduction, what kind of charge we have got? Same kind of charge. Alright. So these are the, if you want, you can draw these three steps diagram. That is for your understanding, better understanding you can draw. Alright. Means these are the 3 steps needed for charging a body by induction. Alright, and when charging a body by induction takes place, remember that the body gains opposite charge as that of the charged body. So that's all for today. Thank you, girls.